Now I would like to say hello and good morning to Frits Ogg, who is an author from the Netherlands, and who will tell us about energy harvesting with very small wind turbines. Please go on, Frits.
Okay, thank you, Martin. No, that's not.
Yes, you are on.
Okay, that's it. Thank you. I'm Frits Ogg, and I'm a researching journalist and partly a guest lecturer, and with a focus on small wind. With this presentation, I will make a point, and that's why I called it an introduction. And I think the discussion about what is small will be broader after this presentation. I'm going to tell you something about energy harvesting, the use of energy harvesting with sensors, a little bit about citizen science, the reason I was looking after these small wind turbines, the use of energy use of sensors, what name do we give on these small wind turbines, a little bit about the interaction between radio waves and small wind turbines, because you can imagine that radio waves have problems with moving objects, and sure some applications. Well, energy harvesting is the conversion of ambient energy, the energy that's around us already, and the conversion into electrical energy. And we use that in electronic devices. One of the most important things about energy harvesting is that you don't expect wonders. It's a very little amount of energy. And to understand energy harvesting, you need a mindset. And I use a cartoon for it. A lot of people, when you talk about small wind turbines, expect too much from such a turbine.
Mr. Frits, I'm so sorry. If there's a screen, we don't see it. The cartoon you mentioned.
Okay. You don't see this one?
Nope. Not me anyway, but my program might.
I confirm we don't see
this safe. Okay.
There we go.
Yeah, okay. This one?
Yes, super.
Okay, so this one was the introduction, this the contents. Yeah, okay, we don't miss a lot. Sorry. I use this cartoon to show that a lot of people look wrong at small wind turbines. Everyone wants a small wind turbine on their roof to get all the electricity for their home, but it's not possible. And energy harvesting is less energy. Well, energy harvesting is a broader thing. We use it already in wristwatches, and you can power the watch by moving, or by solar, or by the difference in temperature between your body and the surroundings. We have photovoltaics. We have also thermoelectric generators. that's used at the moment commercially at central heating installations. You see a valve that's operated by the temperature difference between the heating installation 50 degrees centigrade and the ambient, let's say 20 degrees centigrade. This difference in temperature is converted into electricity and put into a supercapacitor. And when you need to switch the valve, you have power. So there's a very broad, there's much more ways to get small amounts of energy. Piezoelectric and vibration is something that's for wind energy at the moment experimental, but we will see. This topic is more about the electrodynamic application, in which I will tell you something. Well, we are using the energy from this energy harvesting to power sensors. And for wind energy, we know we have the sensors to measure wind and wind speed, for instance. Well, if you have more sensors than one, you have a sensor module, and on the left you see one of the sensor modules I have. You can see I'm measuring several things. This is a citizen science project. I will come on that later. And all the data is open source. So you can find the data from my sensor and all the sensors in my city on the internet, and you can use it freely. There are a lot of these modules on the market. On the right side, you find another one. Okay. It's not much energy, so you need energy management. You see here a black box. That's, for instance, a solar cell, or like this one, a wind turbine, a small wind turbine. You have a microcontroller, and it's a very it has a very low quiescent current, so it's don't use much power, and you need this microcontroller handles the data from the sensor and send the data also to a transmitter that sends the data to a central server. And the energy will have a battery, a rechargeable battery, and the energy is regulated by an electronic component who does so. In the last years, sensors have become very, very cheap. That's the reason a lot of sensors are used to measure a lot of things in the world by citizens, but also in the industry. And the growth of these sensors is shown here. So it's a huge growth of sensors, and all these sensors are using energy. When you are measuring, you are generating data, and this data is sometimes called telemetry. It's from the Greek. It's words are tele and metron, remote measuring. You have a sensor, you generate data, you process these data, you transmit it, and then you send it to a central server to use it. Normally we use Wi-Fi. We all know Wi-Fi, but there are a lot of more protocols and frequencies we can use, and one of them is LoRa. It stands for long range, and recently a lot of data from these sensors is sent via satellite. Well, this is the sensor module at my home. On the left side, you can see it. You can see it again on the right side. And then you see a black cable going into one of our windows. This sensor has sends its data by Wi-Fi. So I don't need a cable for Wi-Fi, but I need a cable to power the sensor. And it's powered by USB. And the USB cable is, the maximum length is 8 meters. So you can imagine it's 6 meters outside, 2 meters inside to get this sensor powered. Then I have a problem, because for instance, when I wanted to measure the wind speed, wind direction, then that's not an ideal place. So this sensor should be, I'd like to place it everywhere I want. And that's the reason I want to give it an independent renewable energy powering. No, okay. Then how much energy do we need? It's totally different of which sensor you uses. But this is a sensor, the battery case of a sensor from one of the projects in the Netherlands. You see, you can use 3 batteries, and these batteries are changed yearly. So it's a little bit technical, but you use then 3 ampere hours a year, and that's about 8 milliampere hours a day. And that's the power consumption we need to fill. The advantages, we have no power interruption due to bad batteries. A few years ago, I had a wind measurement from better generation with a 9-volt battery, and I put it on my roof. And I had to leave it there for a year. And then after a year, I put it down to get the data out of it. And then the batteries only lasted 2 months. So batteries can be bad. You are free to place your sensor. In principle, the energy with renewable energy powering is for the whole lifetime of the sensor. You can place it and leave it and get the data out of it. And you don't have to go on the roof or in the top of your metering mast for your energy. Well, something about the batteries. Normally, all these sensors are powered by batteries, and we are using more and more batteries. And James Myers, one of the chipmaker arm, that states, if each of the trillion wireless sensor nodes that are projected used a small lithium coin cell, it would require over 100,000 tons of lithium. That's almost 3 times the current worldwide annual production. So we have to get rid of all these batteries. Well, now, why hybrid? Why wind? Well, in one of the applications, I will show you that solar panel isn't enough. We know all the calculators with some little solar cells, but in winter we have too little sun at a lot of places on Earth. So well, sometimes you have also to work in the shadow. So hybrid wind can be very good to complete the energy powering. And then especially energy management is the silver bullet for increased reliance upon renewable energy. We need energy management in these situations. Well, I hope you like these graphics. We have now we have very small wind turbines. And there's a lot of confusing names: mini turbines, micro turbines, pico turbines, wind turbines, small turbines. But if you have such a turbine, how what name would you give it? And I think, and that's a suggestion from me, to use the System International to give such a turbine a name by the size of the generator. So you have DC watt, centiwatt, and milliwatt, for instance, wind turbines. Another thing I want to point out a little bit is passive intermodulation. That's the interaction between small wind turbines and radio waves. Wind turbine is a moving object, and passive intermodulation does need a moving object, but every object in a radio wave gives this problem. And there's a Danish, if you want to know more about it, there's a Danish professor, Dex Stannerby, who has a very nice video, a technical video on the internet. Just to point out, it's also a point. Well, for the moment, we have some toys on the market, and some of you will have seen these toys already somewhere, and it's also used already as the toys are used to harvest wind for instance, such a sensor or sensor node. But imagine these are ventilators. It's coming from Asia, ventilators, a mass production, but when you use them as a rotor, they are designed on a resistant base. So as a rotor, they could they could have a lot of improvement. This is this was also an option. The wind goes through this one and brings a wire in vibration, and then you have a coil and a magnet, and generates a little bit electricity. There are also more serious applications. On the left side, this is a Swedish company, Revip, but they don't use wind. It's used in the wind industry, but they don't use wind, they use vibrations. There is some research in which you convert a rotating rotor into vibrations to power to use the power in this unit. This is used on a big wind turbine. The tower is vibrating, or a blade is vibrating. The vibration is used to harvest energy, and is used to send the data to the central server. The other one is one of my favorites. It's UNAFCO. UNAFCO is a non-profit university-governed consortium that facilitates geosciences and education and has hundreds of these stations worldwide. 50 years ago, they had to change every month these batteries, and it's places you need a lot of travel, helicopters, climbing, and then they introduced solar, but they discovered that solar did not give enough power in the winter. Then they started to use small wind turbines, these foreground ones, already 25 years used on sailing ships, but in these circumstances only lasted for 1 year. And then with the manufacturer, they started a program, and then they developed in 7 years a wind turbine that's now maintenance free for nearly 15 years. So the combination of solar cells and small wind turbines gives a year-round electricity, and now at some places they only have to change the batteries in 5 years. So that's much cheaper than in the past. Well, these turbines are black. That's what I wanted to say about it. And that's because these black turbines have not so much ice forming as other turbines. Then it's going too fast. Yeah. Then this is like a more traditional wind turbine. It's on the left. This is a research one, an experimental one from Virginia Tech in the United States. So you see, it's 72 millimeters, 7.2 centimeters. It's a very small one. Then we have one that's used on the second Jindo Bridge in South Korea. They had to measure vibrations on the bridge, very high, and they developed a small wind turbine that could power these sensors. And then there's at the moment a lot of electronics to harvest and regulate your power. Well, well, I think energy harvesting with wind can be a supplemental source of electricity at remote and inaccessible places to power sensors and transmitting data of sensor and sensor modules. And energy harvesting gives the freedom to place the sensor at any place you want, and is more reliable than batteries. Can also be a solution for the growing impact of the use of non-rechargeable batteries. And I think the nomenclature of wind turbines, I prefer the use of prefixes out of the System International. It was a little bit of discussion yesterday. It's now not about efficiency. It's about fulfilling the needs you need, the energy needs you need at this location. It's more important that it's reliable and it's cheap. And like the discussion yesterday about the ONIPCO rotor, if there's a rotor that's usable, it's not really an efficient rotor, but it's usable in low winds, well, then this is the moment to use it. It's a very small one. I have put a lot of references for your convenience later on when you get the slides. Thank you.
Thank you very much, Frits. We are a bit behind the time, so if there are any questions, I would like if we could take them in the afternoon. So please write them down so that we'll take it up later.